All right, today we're going to get our hands dirty. And I mean that literally. We are digging deep into the world right under our feet to really understand the basic properties of soil. You know, it's something we all kind of take for granted, maybe call it dirt, but it is an unbelievably complex and absolutely vital living system. So, let's get into it.
I mean, just look at this. You might see a handful of dirt, right? But what if I told you that's one of the most sophisticated materials on the planet? Seriously, this soil has its own architecture, a specific recipe of ingredients, and this hidden chemical power that makes pretty much all life on Earth possible. So let's break that down piece by piece.
First up, let's talk about the physical design of soil. And I'm not just talking about the individual little bits and pieces. I'm talking about how they're all built together. You can think of it like the soil's architecture.
So the fancy term for this is soil structure. It's just how all those tiny particles, the sand, the silt, the clay, and the organic matter, clump together to form these larger clusters. And we call those clusters aggregates. And believe me, these aren't just random clumps of dirt. They are the fundamental building blocks of a healthy soil.
And as you can see, these structures can look really, really different. What you really want, the ideal one, is called granular. See how it looks like little breadcrumbs? That shape leaves tons of space, which is perfect for air and water to move through. Now compare that to the platy structure. Those flat, stacked layers can literally stop water in its tracks. And then you have these other types, like blocky, massive, or single grain, and they all completely change how the soil behaves.
So why does any of this matter? Like, what's the big deal? Well, it's all about the space between those aggregates. These little gaps, these pore spaces, are basically superhighways for water, air, and plant roots. A good structure with lots of pore space also means the soil has a low bulk density. It's lighter, it's fluffier, and it's way easier for roots to grow and explore. Okay, so that leads to the obvious question, right? We've seen the architecture, the overall building, but what are the actual bricks and mortar? What are the individual components that make up these all-important aggregates? And to answer that, we have to look at our second big concept, soil texture. So if structure is the architecture, you can think of texture as the ingredient list. It's the fundamental recipe of the soil itself. Basically, soil texture all comes down to the mix of just three mineral particles: sand, silt, and clay. It's the ratio of these three things, which are all different sizes, that determines almost everything about the soil, from how it feels in your hand to how much water it can hold on to.
And you can literally feel the difference. Sand particles, they're the biggest. They feel gritty, and because they're so big, water just drains right through. Silt is the medium-sized particle, and it feels super smooth, almost like flour. And then you've got clay. Those are the tiniest particles, and they get sticky when they're wet. They hold on to water and nutrients very, very tightly. Now, most soils are some combination of these, which we call loams, trying to get the best of all worlds.
Now, to get really specific, soil scientists have this awesome tool called the soil textural triangle. It looks a little complicated, but it's not. All you do is measure the percentage of sand, silt, and clay in your soil, and this chart will tell you exactly which of the 12 major soil types you're working with. Let's do a quick example. Let's say your lab test comes back and you've got 35% clay, 30% silt, and 35% sand. Okay, so you find 35 on the percent clay side and you just trace a line straight across. Then you find 30 on the percent silt side and trace that line diagonally down. Then you do the same for 35% sand. And boom, you'll see all three lines cross right in the middle of the section labeled clay loam. Simple as that. But hey, you don't always need a fancy lab. You can get a pretty good idea of your soil texture right in the field with something called the sausage test. You just get a little soil, make it damp, and try to roll it. If it just crumbles and you can't even make a sausage, that's a sandy soil. If you can make a sausage but it cracks when you try to bend it, you've probably got a nice loam. But if you can bend that sausage into a complete ring without it breaking, well, you are definitely working with a soil that's high in clay. All right, so we've got the architecture, the structure, and we've got the ingredients, the texture. But there's a third, totally invisible property at work here. What gives soil its secret weapon? Its ability to hold on to and supply the nutrients that plants need to survive.
And that brings us to the soil's chemical power. This is an invisible force, but it is the absolute engine of soil fertility. And it all boils down to simple electrical charges. Okay, so here is the secret. The key to the whole thing. The absolute tiniest particles in the soil, we're talking about clay and especially that rich dark organic matter, they are not electrically neutral. They carry a negative charge, and that one simple fact is the foundation for the soil's incredible ability to act like a nutrient magnet.
The scientific name for this property is the cation exchange capacity, or just CEC for short. It's basically a measurement of the total negative charge in a soil. And since you know opposites attract, these negative charges on the soil grab onto and hold positively charged nutrients, which are called cations. We're talking about essential plant food like potassium, calcium, and magnesium. So really, CEC is like the soil's built-in nutrient storage bank.
Let's take a closer look at how this actually works. This diagram shows a close-up of a clay particle. See all those little negative signs on the surface? Those are like tiny magnets. They attract and hold on to those positive nutrient ions, the cations, like calcium and potassium. This keeps them safe, right there in reserve, so they don't wash away. Then, a plant root can come along and basically trade a hydrogen ion for a nutrient it needs. It's this amazing exchange system.
So what's the bottom line? A higher CEC just means the soil can hold more nutrients. It's got a bigger pantry. And soils with more clay and, this is so important, more organic matter have a much, much higher CEC. That organic matter is also a food source for billions of microbes. And the makeup of that food, something called the carbon to nitrogen ratio, controls how quickly those microbes break it down and release even more nutrients for plants. It's a living pantry.
Okay, but what about nutrients that have a negative charge, like nitrates? We call those anions. Well, since like charges repel, and most soil particles are negative, these anions get pushed away. This means they're really mobile and can get washed out of the soil very easily, which is a huge deal for farmers. Now, it's worth noting that some soils can develop a small anion exchange capacity, or AEC, but for most soils, that CEC is really the main game in town.
Okay, wow, we've covered a lot. We've looked at the architecture, the ingredients, and the chemical power. So now let's pull all of these ideas together and see the big picture of what makes a healthy soil system. This table really sums it up perfectly. You need good structure, the architecture, to create physical space and keep that bulk density low. You need the right texture, the ingredients, to perfectly balance holding water and letting it drain. And you need a high cation exchange capacity, or CEC, the chemical power, to store and supply nutrients. But you have to remember, this isn't a dead system. The whole thing is powered by organic matter and the incredible microbial life that lives in the soil, constantly making this whole thing work.
And that really leads to the key takeaway here. Healthy soil is not just some inert medium. It is a dynamic, living system. Its physical design, its chemical magic, and its biological engine, they all have to work together perfectly to support plants and, by extension, to support all of us.
So I'll just leave you with this one thought. The next time you're outside and you scoop up a handful of soil, what are you going to see? Is it just going to be plain old dirt? Or are you going to see the amazing architecture, the perfect recipe of ingredients, and that invisible magnetic force that makes it a powerful, living foundation for our entire world?